There are many different factors that lead to wildfire in California. There's more people moving into the wildland-urban interface. There's more ignitions because of all the people moving there. We have a history of fire suppression, so a lot of fuels have built up. Conditions are getting hotter and drier. But throughout this video, I really just want to focus on the weather side of the fire behavior triangle. Fire behavior triangle is fuel, weather, and topography. Describes how your wildfire conditions are going to change and what they're going to be like. And when it comes to weather, there's four main variables that we're going to talk about. It's temperature, wind, humidity, and precipitation. Now the first one I want to go into is precipitation, because usually that's the one that sets the stage for the wildfire season, because in California we get most of our rainfall during winter, and then summers are the driest part of the year. And if you look at a lot of rainfall plots or graphs for cities in California, at the start of the graph in January, you're at the peak of your rainfall, and then it almost looks like a U shape, where around June and July, we're seeing almost no rainfall whatsoever, and then it starts to go back up again as you get into November and December. So the reason that wildfire is so bad in California is because, or there's a lot of reasons, but part of it is due to this rainfall pattern, which is typical for Mediterranean climates. And the reason this is bad is because at the driest point in the year, you also have your warmest temperatures, where in places like, let's say, Southeast Asia, during their summer months at the peak of their temperatures, which is bad for wildfire, they're also getting a lot of rainfall, so there's a lot of moisture in their fuels. So that's one aspect of precipitation. The other aspect is California is very variable when it comes to our rainfall. And that's talking about on a year time scale, but then also on a daily time scale. So on the year time scale, we could have very dry years for maybe 3 or 4 years or a decade-long drought, but then we could have years where we just pick up a massive amount of rainfall. So if you look at the average inches of rainfall for a city in California, it's actually not that good of a number, because there's such high variability that some years are going to have very little, some years are going to have a lot, and then it just kind of equalizes out over time. So obviously during the drought years, that's when wildfire is going to be much worse, because the fuels are going to be a lot drier. And if you've ever started a campfire, I probably don't need to explain why dry fuels lead to worse wildfire. It's just easier to start, and then it burns faster and hotter once it does. Now within the daily time scale, or within one winter, that's also where California's rainfall is highly variable. It's not like we pick up 20 storms and each of them drops 1 to 2 inches of rain. The majority of California's rainfall actually just comes from a few storms every year. It's what you'd call an atmospheric river a lot of the time, and I believe it's 30 to 50% of California's average rainfall comes from just 3 to 5 big storms per winter. So you might be completely dry for December, and then in January you have 2 atmospheric rivers, and then it ends up being a good rainfall year. So it's very variable in that aspect as well. And that can lead to mudslides and things like that when you have those big atmospheric river events, but I think that's some kind of a topic for another video. The main thing that you need to know there is California rainfall is highly variable, but we have dry summers, and when you have dry summers or just dry years, wildfire is going to be worse. And then I'm actually going to combine our next 2 variables here, temperature and humidity, together, because those usually do follow the same pattern, where if it's hot, it's usually going to be drier, and if it's cold, there's usually going to be more moisture in the air. So I want to focus on humidity more because it's a bit more intuitive for how that's going to impact your wildfire. On times where it's very dry out, so what always kind of makes me a little bit afraid when I'm doing wildfire forecasting is if I see our relative humidity numbers drop into the teens or even worse into the single digits, that means the air is going to be very dry. So the reason that's bad is because that's going to dry out the fuels, and then as I explained earlier, if your fuels are dry, it's easier for fires to start and then spread. And just to explain that a little bit more, the reason that dry fuels burn faster is because when a fire comes up to, let's say, a tree, before it can catch that tree on fire, it actually has to evaporate the water out of the tree before it can burst into flames. So if that tree's already dry, it's going to be ready to burst into flames, and the fire is not going to use any of its energy to evaporate the water out. It all is an energy balance. So if the fire comes up and it has to use a bunch of its energy just to evaporate, then there's going to be less left over to lead to an extreme blaze. And then also within humidity, an important part of humidity is what it's doing throughout the day. Obviously, the worst wildfire time of the day is going to typically be in the afternoon in terms of humidity, because that's going to be the hottest time of the day around 3 or 4 o'clock. And then that's also going to be the driest time of the day. So your wildfire activity is going to pick up. But it's also very important what your nighttime humidity does. And that's what you'd call humidity recovery. If it stays very dry overnight, then you don't have that period where moisture goes back into the fuels. And sometimes that can actually be worse than just a dry afternoon, is if it's dry for a 24-hour time span, because then the fuels have no period where they're getting some moisture back into them. So humidity, pretty intuitive. So I just want to focus last on winds here. And this one, I would say, has a lot more aspects of how it impacts fire, because just right off the bat, if you think of wind and wildfire, you can think of it just pushing the flames forward, and that's going to move the blaze faster. On top of that, it's going to be providing more oxygen to the fire, which is one of the things that fire needs to survive. I believe it's heat, oxygen, and fuel are part of the fire triangle. So the more oxygen a fire has, the more it's going to be able to burn. And then the one that you'll often hear a lot about on the news is spot fires. And the reason this one's bad is, like on the Dixie fire, they could do a bunch of great work putting in containment lines. And then you have some winds pick up, it picks up a burning ember, tosses it right over the containment lines, starts a new fire, and then it's able to just take off. And it can just kind of ruin the progress that we make on a fire trying to contain it. And then those little fires can turn into their own fires, or they can connect with the major blaze, and then that leads to some rapid growth as well. Now with winds, it's not just the magnitude of the wind that's important, it's also the direction that it's coming from. In terms of magnitude, obviously, stronger the wind is, the worse your wildfire is going to be, because of all the factors that I just described. But direction is also important, especially along the California coast. If you think about winds coming from the west, that might actually be good for your fire, because it's going to take some of the cool air, some of the moist air that's over the ocean, and it's going to push it in over your coastal communities, almost like a little natural air conditioning. That also helps moderate the temperatures, so it's not as warm, and then the moisture moving in goes into your fuels. Maybe you get some fog, it drips into your plants. It's almost like rainfall out there. And that is going to be a beneficial wind direction. Now, the winds that you don't want to have are the ones that you could call offshore, but in terms of fire, you've probably heard the terms Santa Ana, Sundowner, and Diablo. Diablo winds are more northern California. Sundowners are offshore winds in Santa Barbara, and then Santa Anas are the offshore winds that you get in Southern California. Now, what happens here is you usually have a high pressure. Shouldn't get too sciencey here, but all you have to know is that you have a high pressure over the continent, and then that's going to be blowing wind offshore, so towards the ocean. So what that's going to be doing is taking drier air, because it's not over an ocean, and then as that goes downhill, or down in elevation, it's going to be compressed because there's more atmosphere above it pushing down on it, and as it's compressed, it's going to heat up. The way I always like to think of this is, if you're up at a very high elevation, there's not that many air particles above you or around you. The air is less dense, so it's going to be cooler. How you could think of that is, if you're at a party in a gymnasium and there's 10 people and you're all spread apart, that's going to be somewhat cool out. But then if you take 100 people and you put them into a small apartment in some college town, there's going to be a lot of heat generated in that room. Well, that's what happens to the air particles as the air moves down an elevation or down a slope. It's compressed by the air particles above it, and then the pressure increases, and then it becomes warmer. And obviously, that's going to be bad for wildfire, because as it gets warmer, it's going to get drier, and then that's worse for wildfire for all the other reasons we've already talked about. Now with wind as well, we often see this with the Santa Anas, is it'll get funneled through canyons. And then that almost reminds me of if you have a hose and you put your thumb over the end of the hose, then it starts going a lot faster. As the descending air goes through your canyons, your winds are going to pick up significantly. And then the other aspect that's kind of related to this is what you see during the afternoon hours in canyons. The canyon walls are going to heat up more, or in valleys, so then that's going to lead to a lot of rising air. And then you get winds rushing upslope during the afternoon. And then during nighttime, the exact opposite is going to happen. Your winds are going to be going downslope. So usually they go upslope a lot faster, so that can lead to pretty rapid growth uphill during the afternoon hours. So a lot of what we've talked about paints the picture for why wildfire is bad in California, but then also paints the picture for why wildfire is worse during the afternoon hours. That's typically when it's going to be the hottest, driest, windiest part of the day. So hopefully you learned something about weather and wildfire in California, and thanks for watching.